To this screencast where we have a special guest with us today, Jay Griffin from Hawaii Natural Energy Institute. And the goal of this screencast is to give you some information about some of the exciting energy-related projects that are going on within the university and within Hawaii as a whole. So thank you for coming to class today, Jay. Appreciate you being here. So maybe start a little bit and just tell us in the 30-second overview of what HNEI is, because I'm sure that a lot of the students have never heard of it.
Sure. So we're a independent research institute within the university. So we're not within a particular department such as College of Engineering. We were created by the state legislature with the mission of helping the state develop renewable energy resources and reduce dependence on fossil fuels. And that was started in 1974. Our staff historically helped drill some of the first geothermal wells on the Big Island. Done a lot of research in their biofuels, OTEC, but more recently, in the past 5 years, we've been doing a lot of projects with the utilities here in Hawaii to help them integrate the variable renewable energy resources like wind power and solar power. And so we'll talk a little bit more about the particular project we're doing on Maui with that as one of the main purposes.
Great. So I've been working with Jay for probably almost a year now on a project that involved the application of the Watt Depot system that you're going to be learning about in class and using as your class project. We did a project earlier in the year where we were acquiring data from a local residential community, using Watt Depot to both figure out how valid the data was and to perform some visualizations of it. So kind of one of the reasons why I invited Jay here today is because the projects that he's working on in the future also have similar kinds of potential forms of collaboration for students who are interested in energy applications, which I think is an important, hopefully something that you'll find interesting and important. Secondly, have some experience using Watt Depot because it's a technology that has some kind of unique attributes and can be well suited to certain kinds of things that they want to do. So tell us about what you're doing on Maui.
Sure. So we received a grant from the Department of Energy, and we're doing a test demonstration with different smart grid technologies. Mm-hmm. We're going to work actually lots of various things. There will be a battery energy storage component, some advanced computer energy management systems, but a lot of the focus will be on different technologies we're going to offer to customers on Maui. And we'll do a quick run through today, but if you go to our website, MauiSmartGrid.com, you can find a lot more information on the project. And this is real live demonstration. As we speak, we're signing up customers over on Maui to host the various equipment in their home and to test out. So maybe a quick rundown. Maui is a small island utility. They currently burn pretty much oil for about 85% of their energy. They have one relatively large wind project and looking to expand that to 2 more. So very soon, very, very large amount of renewable energy relative to the size of the island. Yeah. And the utility faces challenges in balancing the supply and demand of energy.
Right. So the percentage of intermittent power is relatively high.
Very high.
Yeah.
Relative to other places in the world, it's not the highest, but it's certainly it's a contender. Okay. So what are we offering to people? First is
here comes the show and tell part of the presentation.
So what's known as a smart meter, and so you can see here in the right here in the camera, it's actually just a normal digital meter that includes it measures energy consumption at the home, but what makes it smart are some two-way communications. You can see the chip in here. Yeah. So it provides communications and memory. So the meter can store energy consumption information and then periodically downloads it to a database at the utility. The meter can also communicate to different devices in the home, and we'll get to that in a second.
So it's energy, not power.
Sorry, it's actually it is both.
Okay.
You can,
okay.
yeah, it measures both. So, and can download that in real time.
And about how frequently are you sampling the data from these meters?
We will program them about every 15 minutes. It will be recording that and then downloading that information. I believe it's every 4 hours.
I see.
Generally, some of the meters will be configured a little bit differently, but that's
Right.
the general idea. So contrast that to the situation today where you receive your energy bill at the end of the month. You don't have, unless you've installed things in your home
Yeah.
to monitor your consumption, you don't have any idea how much you used until you get the bill at the end. So a couple of things, what can we do with the information is that's downloaded to the utility. It's made available to a website that everyone will have an example, will have access to, similar to what some of the work that you guys are doing. But this will be made available to residential customers on Maui, showing them how much energy they're using in various ways. So
Yeah.
you can, it's one example. Another is I had talked about how the meter can talk to different devices in the home. This is well, it's not running now, but an information display that will show the consumption information in real time. So if you want to see things more frequently than every few hours, this will be
Right.
communicating the actual power measurements in real time. So these are all part of the project is we'll be looking at how people change their behavior. We can compare the data from before they receive the meter and the different accessed information and afterwards, and we'll be collecting, so information will go to the utility, but will eventually come here to the university, and we'll be doing analyses on how people's behaviors change before and after receiving the different devices I'm showing here.
That's great. That's great.
One other example is what's known as demand response technology. I had talked about in the beginning how to use some of these technologies to help balance the supply and demand for power. So here's an example of a smart thermostat. If you have air conditioning in your home, this can receive signals communicated through the meter and raises the temperature set point, effectively turning off your air conditioner. It's used for short periods, 20 or 30 minutes. But with enough of these out, if you had thousands of customers with these, that provides enough potential reduction to be a value to Maui Electric. So one question I'm always asked is why would you allow the utility to shut off your air conditioner?
Right.
So if you look at other places, these are parts of programs that utilities offer to their customers. So typically you receive an incentive on your bill. Provides a value to the utility because this helps them from build either blackouts in the short term or building new power plants to provide the same service.
Right.
So there's generally benefits for everybody. If it's used correctly, you still have cool air in the home if it's only turned off temporarily. And if you have enough of the people on the island, you can imagine that you could do this type of program. So in our case, we're looking up to about 200, but it's really to give people, both the utility and the customers, a chance to test out that everyone is okay with using this type of technology.
So basically the utility will communicate to the meter, the meter communicates to the thermostat.
Exactly.
That's the control pathway.
Yeah, and we will then, through the information collected again, we'll be able to show at a certain time, if you send out the signal, how many of the, depends on if the air conditioner is on or off at that particular time. So we can build a statistical database of what fraction of air conditioners happen to be running at certain times of day. And then this information, when compared to the output of renewable energy varying over time, those are comparing that data before and after through the project. Those are the types of analyses we're looking to do.
Right. So from a kind of an environmental standpoint, I mean, you can put a windmill up and the turbines can spin around.
Yeah.
But is that really saving you any oil? And the answer is could be or could be not, depending upon how well they can balance and predict the actual load. right?
Correct.
So oftentimes you can have a windmill producing power, but they can't actually use that power. They have to just kind of dump it.
Yeah,
right?
so what Philip's talking about right now, a lot of times at nighttime, the power demand on Maui is about half of what it is during the daytime. And the utility needs to keep a certain number of their traditional generators online to help maintain stability. And there are times where the windmills are producing more power than the utility can take, and it's literally dumped.
Yeah.
So another feature of what we're working on is different types of pricing programs that would give you an incentive to use more power at night. These types of smart meter communications support all of that. You would have a lower rate at nighttime than you would have during the daytime. So that would, give you incentive to maybe turn your dishwasher on a little bit later in the evening, turn your washing machine on, and if you have thousands of people doing that across the island, it starts to make enough of a difference that you can effectively measure these things and see what the impact is.
Yeah, I think it'd be interesting, personally, if we had a project that maybe a student might do that modeled what customers do if they had access to the actual power output of the wind plant. So, for example, you could make the community an actual active participant in optimizing the usage of the power being created by the wind turbine. And I think that could also drive things like electric vehicle adoption, where they could kind of charge their cars at night if they noticed that there was some excess capacity. So it seems like there's a lot of opportunities for student projects, not just kind of helping with the data analysis of this, but also maybe building simulations or models or kind of proof of concept systems that go beyond or go to the next stage beyond the infrastructure that you're creating right now.
It's a good thought. I mean, you're absolutely right. We actually, one of the features with the display here is that the utility can send messages to you.
Yeah.
So to the extent that we can try and program in the ability to send that type of alert to customers, we have essentially free wind power on the system right now, and see if people respond. I think it certainly would be worth looking at.
Yeah. I mean, I think that part of the problem is the public has a mistrust of the utility, in the sense that they think that the utility is just trying to rip them off, or do X and Y, and that one of the things I think in the university system that we can do is we can be imaginative about ways that information technology can be used to actually empower consumers and create more transparency, so that the consumers feel like they're actively being part of the solution, and maybe some of that mistrust that comes from the opacity of the current electrical system. And I just want to comment that for 100 years, we've had a very opaque electrical system, and that's actually worked to our benefit as consumers, because we've just assumed that whenever we wanted power, we'd always have it, and it'd always be cheap, and it'd be reliable. And the utilities did a great job of insulating us from all the nitty-gritty details. But that's coming to an end. Now we have things like demand response, and I think we all as citizens have to move to a new place with respect to our relationship to energy and our relationship to the utilities. Tell me about just a little bit about solar power as opposed to wind power, and how that is being used on Maui, and what kinds of stuff you're doing with that.
Great. Yeah, no, very good question. So if you look at the data, the number of systems, so we're talking rooftop photovoltaic systems, the numbers of those installed every year has doubled since 2005. So it started from a very small number and is quickly becoming, now it's roughly 8 megawatts, which is about the size of one of Maui Electric's small generating units in a power
peakers.
plant.
Yeah.
So it's becoming, a very important contributor to the system. One of the challenges they face in particular with those systems is they receive they can't, that is basically a small power plant operating on the grid with no information on it.
Right.
If your job is to in real time always balance the supply and demand of power, or the lights go out, that starts to add challenges as the amount of power from that source goes out, increases. So we were actually, through the project, we're looking to work with photovoltaic system owners and install a small wireless monitoring device that will communicate through the same network. And so it'll measure the power output in real time from the PV system, transmit that to the utility, and we'll be kind of aggregating that. So they'll see a signal saying there's X amount of power coming from this neighborhood. And the idea is that if you have this type of communications, that's a relatively low cost way of measuring and transmitting that information.
Right.
So
is that the so-called smart inverters, or is that something different?
So that will be a feature in the future of smart inverters, which is actually, well, we can get into that in a second. That's an add-on part of the. No, it's an add-on to the project. So the first part is just the information about power output. Second feature is now, so assuming you have that, you still don't necessarily have ways of helping to manage the variability, and that gets at what you were talking about in the smart inverter. So an inverter is what takes the panels, provide what's known as direct current, and we all use alternating current in our home. So that makes the conversion actually it's incredible how sophisticated the technology is now in a small device that you put in your home to enable this. It's pretty incredible once you start to see what goes into it. So we've also received funding to do some work with a couple of companies advancing that technology, and we're going to test it out here on Maui. And the basic of that is that those new inverters will have features that operate very much like the power plants that Maui Electric has. So when there's imbalances in the system, the inverter can respond by increasing and decreasing output, different ways of helping manage the voltages within the system. We'll have the wireless communications embedded into it so it can connect directly to the meter. So we'll be actually doing the development with those companies, both the company doing the communications part of the system and the inverter side. So in the next year, we'll be working with those companies to do that, and then it's kind of a phased approach here. So we're working with the customers and installing all of the meters and various equipment, and then once the inverters are ready, we'll be looking to work with some more Maui Electric customers. So what does that mean for some of the folks here? One is we have long-term projects with lots of interesting things to work on, particularly as we get into the PV side, because we'll be able to measure what is the effect of, we can turn some of these functions on and off, measure how does that affect both the power in the home, some of the local properties of the electric system, voltages, and so on. So that is particularly exciting. I was just at a meeting with the Department of Energy earlier this week over on Maui, and their main person kind of opened up the whole conference talking about the project that we have going there. So it's very, very high profile within the solar industry.
Excellent. So just to conclude, one of the things that I'd like to have you think about professionally is that I think a huge growth area in software development and software engineering is our electrical infrastructure. All of these things are requiring more software than has previously even been imagined for, by the utilities. In fact, the whole concept of the smart grid is that utilities need to manage information just as much as they need to manage power. And that's a brand new thing for the utilities. And to be quite frank, I don't think they're that good at it. There have been a lot of kind of snafus. There's a lot of security issues. There's a lot of public relations issues around this manipulation of information. So I think this is a place where the software engineers of the future can play a great role in our society in terms of creating the kinds of software that help us as citizens transition to an infrastructure that's less dependent upon oil, more dependent upon renewable resources in a way that meets the challenges that renewable resources are associated with, such as their unpredictability, their intermittency, and so forth. The take home here is that UH is doing a lot of exciting stuff. Jay didn't mention, but they have a $6 million grant for just one of the projects on Maui. There's a lot of funding being made available to do these projects. And so if you can step up to the plate, get proficient with this kind of technology, I think that there's some great opportunities for you at any level, bachelor's, master's, PhD, doing either semester-long projects or thesis-level projects, or RA-ships or internships. The whole spectrum of opportunities are available to you. Any last words?
No, I can't emphasize that enough. I mean, a lot of in all these programs, people talked about green jobs and been working with a lot of these companies. I mean, the IT side, the software engineering, is one of the, if not the best growth area of all this in the future. And so in these projects, we're working with kind of some of the leading edge companies in the world. And so there's lots of good opportunity to learn from and have future job opportunities.
Okay, great. That's Jay Griffin from HNEI. Thanks so much for joining us today.